So we've talked about solving equations, two-step equations, equations with distribution, equations with like terms. Now let's move on to equations where you have variables on both sides. Okay, we have an example here. 5n minus 2 is equal to 3n plus 6. So we're going to try to find the value of n that makes this equation true. So let's do this. First thing let's do, I'm going to rewrite my equation. So I have 5n minus 2 is equal to 3n plus 6. Okay, so what makes this different is now I have variables on both sides. Earlier on some of the equations, we had variables on the same side and we would combine them, right? So if 5n and 3n were both on the same side, we would just put them together and combine them. But now we have them on both sides. So what we're going to try to do is we want to remove them from one of the sides. We want to get rid of them from one of the sides. So you have to decide, do you want to get rid of them from this side or do you want to get them rid of from this side? Now there's a bunch of different reasons why you might do one. Maybe you like the variables on the left side. That's fine, you can do it that way. I personally like to keep my variables positive, going up if possible. And so in order to do that, I evaluate 5n and 3n as to see which one is a larger number, okay? Which one is higher. Well, positive 5 is higher than 3n, so I'm going to try to get rid of these. Okay, so how do I do that? Well, this is being 3n is being added with 6. Okay, so in order to get rid of this, I'm going to use that thing that we call the additive inverse. Okay, the additive inverse. Okay, the additive inverse is what you add to get to 0. Okay, and it basically means the opposite. So what's the opposite of 3n? Positive 3n? It's negative 3n. So I'm going to add negative 3n to this side, and I'm going to draw my line through the equal sign just to make sure that you balance it out. And I'm going to put a negative 3n on this side. And I'm going to combine these. Well, these two cancel each other out, right? It becomes 0. So then I'm going to be left with a positive 6. Okay, and I like to keep the positive in there. And then I have 5n minus 3n, or 5n and negative 3n, which will give me 2n. And I bring this down, and I'm going to rewrite, I'm going to make this plus a negative 2 plus negative 2 is equal to 6. Okay, well now I have my variables all on one side. And now this is a two-step equation, okay? And then what I'm going to do is I'm just going to use my steps to solve it. Okay, if I knew n, I'd multiply by 2, and then I would add negative 2, or then I would go down 2. So to reverse that, I'm going to go up 2 here, and I'm going to go up to here. And I'm hoping that this, you'll start seeing, like, this is going to be helpful for us to get to the answer here. Okay, these cancel out, so I'm left with just 2n is equal to, and then positive 6 and positive 2 make positive 8. Now I'm going to divide by 2, and I'm left with n is equal to 4. Let's go ahead and check our answer. Okay, so I'm going to do this. I'm just going to sort of do it in red above. I'm running out of space, so we'll do 5 times 4. This will be 20 minus 2. Okay, and then 3 times 4 is 12 plus 6. Okay, and 20 minus 2 is 18. 12 plus 6 is 18. It checks out. Okay, there you go. Let's try another one. Okay. Actually, why don't you do this? Why don't you go ahead and, for example number 2, why don't you pause the video and you either try the whole thing or just try to remove the variables, try to get the variables to one side. Go ahead. All right, hopefully you had a chance to try it. I'm looking here, I have a positive, let's rewrite it, 8y plus 4 is equal to 11y plus negative 17. Okay, plus negative 17. All right, so now let's look. This is a positive 8 and a positive 11. Positive 11 is higher, so I'm going to remove 8y from both sides. So I'm going to add a negative 8y to both sides. That's going to leave me with these cancel out. I'm left with a positive 4 is equal to, that's going to be 3y. And negative 17. Now, from here, I'm going to add positive 17 and a positive 17, and I get 21 is equal to 3y. Sorry, I'm running out of room. Divide by 3, and y is equal to, divide by 3, y is equal to 7. Okay? y is equal to 7. And then let's try it out. Okay, so 8 times 7 plus 4 is equal to, let's see, that's 56 plus 4, which is equal to 60. Okay, so the left side right now is 60. And then 11 times 7 minus 17, that's 77 minus 17, which is equal to 60. So it checks out. Okay? All right, I'm going to get rid of those. And in fact, let's go ahead and I'm going to move, let's see, I'm just going to get rid of that for now. I should have done this on 2 separate pages. And we'll go ahead and move this up. Okay. And let's go ahead and solve this one. Okay. Why don't you go ahead? Why don't you try solving this one all the way on your own? Go. All right. Hopefully I had a chance. I'm going to go ahead and take a look at this one. Okay. I'm going to let's rewrite it. Negative m plus 1 is equal to negative 9m. And I'm going to change that to plus negative 15. All right. This is a negative 1m. Negative 9m. So what I'm going to do is this is a higher number, right? Negative 1 is actually above. Let me write that negative. That's a little sloppy. Negative 1. Okay, negative 1 is actually above negative 9, right? This is 1 below 0. This is 9 below 0. So what I'm going to do is I'm going to get rid of these. So in order to do that, okay, I have negative 9. What's my additive inverse to that? Positive 9. And I put a positive 9m. I'm going to do the same thing here, positive 9m. I'm going to combine my terms here, okay? Let's make sure negative 9 and positive 9, these cancel out. I'm left with negative 15, okay? Actually, let's stay consistent here, and let's write it directly below, okay? And then I'm going to get negative 1 and positive 9. That's going to give me positive 8m plus 1. Okay, now I'm at a two-step equation. Okay, I have positive 1, so I'm going to add a negative 1. Okay, I'm going to put a negative 1 here. All right, and I'm going to be left with those cancel out. I'm left with 8m is equal to negative 15 and negative 1 is negative 16. Okay, divide by 8, divide by 8, and I get m is equal to negative 2. All right, let's try it. So I'm going to do this. We'll do them over here. We'll do negative m plus 1. Okay, and we'll see what that equals. So that's negative 2 plus 1. So the opposite of negative 2 is positive 2 plus 1 is equal to 3. Okay, now let's try this. Let's do negative 9m minus 15. So it's negative 9 times negative 2 minus 15. Negative 9 times negative 2 is positive 18 minus 15. So 18 minus 15 is equal to 3. They check out. Looks good. Okay, let's move on. Now, here we have one with variables on both sides, and we also have our parentheses. We have distributive property, okay? Well, let's just use the distributive property here and break open those parentheses to start with. So I'm going to rewrite my equation. 2x plus 1 is equal to 10x plus 5. Okay, and then I'm going to multiply each side. Okay, so 5 times 2x is 10x, and 5 times 1 is 5. And that's equal to 10x plus 5. All right, now I'm going to look, I have 10x here and I have 10x here. So I'm going to look at that and I'm going to say, well, let's see. I guess I'll just, if this is a positive 10x, let's do the additive inverse of that. So that would be a negative 10x here. Okay, we'll bring our equation down. And so then we'll do a negative 10x here, right, because this is really a positive. Okay, and then we'll combine our steps, and what's going to happen is these will cancel out, and I get positive 5. And these actually end up canceling out too. That becomes 0, and I end up with positive 5. So, that's odd. It's kind of interesting. Well, let's see. So I have positive 5. Let's do the additive inverse of that, and that would be negative 5, and add negative 5 here, and I'm going to end up with 0, and that equals 0. And what happens there is this is true, right? 0 is equal to 0. Okay, this is also known as when something is equal to itself. It's called the identity property. Identity property. Okay. It just means that anything is equal to itself, right? In fact, here 5 is equal to 5. Okay, and when then, actually, even when we got to this step, right? Positive 10x plus 5 is equal to positive 10x plus 5. So what happens here is it actually doesn't matter what x is. In fact, we could plug any number that we wanted in for x, and it would actually work. So there are an infinite amount of solutions. Infinite solutions. Okay? No matter what you choose, it's going to work. Okay? An infinite amount of solutions. And infinite we can use as that sort of sideways 8. Okay? So once you get here, you can either do like, I think the book will say identity. Okay? I'm okay actually if you put here, if you decide to write infinite, if you want to write infinite solutions. And let's just go ahead and test it. So let's do, we have 5 times 2x plus 1. Okay? And what we'll do is let's pick two different numbers and we'll see if it works, okay? So we'll do, if let's say x, we'll do x is 1 and we'll do x is 5, okay? We'll just try those. So then we'll do 5, right? 2 times 1 plus 1. So that's going to be 5 times, well, 2 plus 1 is 3, and that's equal to 15. Okay? Now, let's try the other side, right? We'll do 10x plus 5, and we'll see what that equals. Well, that's 10 times 1 plus 5, and that's equal to 15. Okay, so that works. All right, well then let's try another one here. All right, we did 5, okay, or we did 1. So this one checks out. So let's try, let's switch this around and make it 5 and see what happens. Whoa, whoa, whoa. That went crazy. That was more than I wanted to be erased. Let's just erase it like this. Okay. In fact, actually, I don't want to erase all of that. I just want to really erase this and that. Okay, now we'll plug in 5, and we'll do 5 times 2 times 5 plus 1, and that's going to be 5 times 10 plus 1, 11, which is equal to 55. And then I have 10 times 5 plus 5. Well, 10 times 50 plus 5 is equal to 55. So see, we have two different solutions that works. In fact, we could plug in 3 and it would work. We could plug in 9 and it would work. You plug in negative 1 million, it would work. You could plug in 1/4 and it would end up working. You'd end up with both sides equaling, okay? Because this and this say the same thing. So you'd have an infinite amount of solutions, okay? So far we've seen that you could have one solution, right? I just went back a problem. You could have one solution. Well, we could have an infinite amount of solutions, meaning you could have many, many, many solutions. So then there's another option if you think about it, which is if you can have one option and you could have many, 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 many options, then what's left? Well, you're going to end up with something that looks like this. Okay? This is an example here, so let's go ahead and we'll rewrite it. And again, we have distribution and variables on both sides. So let's break this open. Okay, let's use the distributive property, and we'll get 6x plus 2 is equal to 6x plus 8. All right, and then I have 6x. I have the same amount on both sides, and this is a positive, right? So we'll do add a negative 6x and draw this line down the middle, and we'll do negative 6x here because this is a positive. And when we combine it, we're going to get 2 is equal to 8, right? And this is a positive 2 and a positive 8. And if you look at this, there's nothing we can do. 2 can never be equal to 8. It's just not possible. I can't get 2 to equal. 2 and 8 are not the same. So what this means is this up here, okay? It's impossible. There are no solutions there's no number you can put in here and here that will make both sides equal to each other. Okay, so what happens here is there is no solution to this. Okay, nothing will work no matter what you put in. Okay, sometimes what happens is people think, oh, they get to this point and they say, oh, well, x is equal to 0. But if you think about it, if x was 0, 6 times 0 is 0, plus 2, your left side will equal 2. Well, here, if you made this 0, 3 times 0 is 0, plus 4 is 4, 4 times 2 is 8. Well, 8 and 2 don't equal each other. So again, even if x was 0, this wouldn't work. So it's not that x is 0. There is nothing that works. There is no solution. And there's a shortcut way of writing this, of course, since mathematicians think that that's actually too much to write. So we do a 0 with a line through it, which means there is no solution. There's no possible solution to a problem that looks like this. Okay? Well, I'm hoping you have a pretty good understanding here, okay, of what this looks like. And I think I actually made a mistake here. I think... Oh yeah, I went backwards. Sorry. No, I think I just read. This is supposed to say example 5, I think, instead of. Yeah. So this should be example 5. Sorry about that. So you should have enough examples here for you to be able to succeed in class tomorrow. So I'm going to give you an assignment in class tomorrow, and you're going to go ahead and work on those. And yeah, you should be able to find some success with this. So. Yeah, so good luck.